All right, so in this video, we're going to talk about reading the data in R. Let's first have a look at the data as to what all features does it contain. This is a comma-separated file which has certain features about a retail loan application. So we have the age of the applicant, we have the gender, we have the balance that the person maintains in his or her account, we have the occupation of the person, whether it's a self-employed person, a business owner, or a salaried professional. We have the age bucket of the person, we have the credit score, and the final status, whether the loan for this person was approved or not. We'll be using these features to create some plots exploring the descriptive stats of this data. Descriptive statistics is about what your data already contains. Can we represent this in the form of certain central tendencies like the mean, median, and can we also check the spread or the dispersion of the data? We'll try to do some basic data visualization using this data. Now we are back to R and we want to start working on our data. First of all, by importing the data in R, and then we will start creating some plots. Before we do that, it might be of interest for us to ensure that whatever we do, we are able to save it and reuse it. In order to facilitate that, we have an option in R to create an R script. Now you can see this is a new window where you can type your commands, type your notes, and keep on saving it by simply clicking on save. One of the first things that we have to do here is that we have to tell R where is our file located. The file that we want to read here, what's the path to it? This can be done by using the function called setwd, which stands for set working directory. And in quotes, you have to mention the entire path. Let's go back to the location where this file is, and we will just copy paste the path in RStudio. So you can see on top here, this is the path on my system where this file known as retail data, which is a comma separated file, is available. All I need to do is copy this path from here and paste it in R. So here's where we were, and I will just do a copy paste. Now, one change that we have to make every time we copy a path here is that we have to change the sign of these backward slashes to forward slashes. This is something that we have to do in Windows. In Mac, by default, it will be a forward slash. You don't have to worry about that. Okay, so now that I will hit Control Enter, or I simply hit run here, the directory will be set. R would know where exactly the data is, which I'm referring to. So when I've done this, this is all set. Second step would be to read the data, okay? We can store it in an object called retail. We are free to give names to the objects. The only thing is that it should not start with a special character or a number. I'm creating an object called retail where I'm going to read this CSV file using this function called read.csv. Now, don't worry too much about knowing about the functions. This is something that you easily pick up with practice. In quotes, I need to mention the exact name of the file that I have. So this is going to be retail underscore data. And I also need to tell what type of file that is. So that's actually a CSV file. I can do a Control Enter to read this file in R now, okay? One of the first things that we do whenever we read the data is to explore the data. So this is done with the help of structure and summary. So let's check the structure and summary of the data. In order to do so, we have a function called structure, and you need to pass the name of the object where the data is stored to this function. So let's just write structure of retail. And if I do a Control Enter, I get an output like this. Now this gives us a lot of information. This tells us this object is of a type called data frame. What are data frames? Data frames are typical row column arrangements where all the columns are of the same nature. So for example, if I have age, it contains integers, which are all numbers like this. If I have gender, it has a factor variable, which has 3 levels, male, female, and others. Okay, so this is a quick snapshot of the overall data that I have that I'm getting to see here. It tells me this is a data frame with 4,354 observations of 7 variables. So these are the number of rows and these are the number of columns that we have. And what are my 7 variables? These are the 7 variables that we have. So we have age, gender, balance, occupation, age bucket, score, and approval. It also talks about the data types. As I said, first one is integer, second one is factor, third one here is numeric. So integers and numeric, you can say integer is a subset of numerics. Essentially, these are numbers. Occupation is again a factor. Factor is something which is a categorical variable. Let's say there is a variable called color that we have, and it has 3 levels: red, green, and blue. Now, these are qualitative variables. So it would not be fair to say that red is greater than blue or blue is greater than green, right? You don't want to do those comparisons because these are simply the levels of a category. So such variables are read as factors in R. There are times where you might have to make corrections because R might be confused in reading a particular variable, but more of that will be discussed as we progress through the course. Now let's check the summary. So one of the good things in RStudio is that you keep getting hints also. You can just straight away go ahead and click on that and complete your command. So here we have a summary of retail, and when I hit enter, you will see some numbers coming in. So for your convenience, I will drag this window a little bit so that you're able to see it better. Now, what do we see here? So we see the variable age has been explained as a 6-number summary. What is it? It contains the minimum value of age. It contains the maximum value of age. It contains the first quartile, which is the 25th percentile. Simply means that 25% of the observations are below this value and 75% of the observations are ahead of this value. It contains median, which is the 50th percentile. This essentially divides the data into 2 halves. It contains the mean, which is a sum total of all the values divided by the total number of observations. It contains the third quartile, which is the 75th percentile. 75% of the observations are below it and 25% of the observations are ahead of it. And it also contains the maximum value. Likewise, for a categorical variable, which was a factor, we see that it simply gives the count. So how many females do we have? 935. How many males do we have? 3,361. How many others? We have 58 here, right? Balance, again, because it was a numeric variable, we will see a 6-number summary. For factors, we will see the counts. For the numerics and integers, we will see a 6-number summary. So that is what we have in front of us. Now, approved or not approved, this so far is being taken as a numeric variable, whereas it is actually a category. So what we can do is we can easily go ahead and make that correction. How do we do that? So I'm writing a note, convert approval to factors. Now it's very simple. We have to refer to the column of the data, which is called approval, and we have to convert it to a factor. So the way to do that here is that you go to the data, $sign approval, which means that we're referring to the approval column of the data set called retail. We want to convert it to a factor. So it's very simple. We are replacing the column called approval of the retail data set to a factor type. It was originally listed as an integer, and we are converting it to a factor. So now if I want to check the class of this variable quickly, I can go ahead and type the class of this variable called approval is, you can see it is a factor now. Originally, if you remember, the way it showed up in the structure, it was listed as an integer. And that's why we were able to see a spread of this variable. Approval is one variable which only had zeros and ones, no values in between. That's why it didn't make sense to check a spread of this variable like the way we can check it for numerics and integers. We know that it was only a 0 for cases where the loan was approved and 1 for cases where the loan was not approved. So now that we have converted this variable to a factor, we can once again run the summary and see if it shows a difference. So let's just do a summary of retail, and I'll do a control enter. So you can see nothing else changed, but as far as this particular variable is concerned, now it's showing the counts. More on this in the next video.